Okay, good morning, students. Welcome back to our Zoom class. As you know, in our last class, we discussed on limits, and I gave you some examples and then some activities you have to do. So, what I'll do, I'll go over the activities, the worksheet that you are supposed to do and submit. So, the first one, example one, it says limit as x approaches 0 cos of x. So, what's the first thing you have to do is the value of x, right? The number to which x is approaching, you just substitute that number and check what is the answer, right? If you're getting an answer which is not 0.0, then that means that is the limit, right? Or if you are getting an answer that is undefined, that means limit does not exist, right? Okay, so let's see. When you put 0 x, cos of x, when you put in the calculator, you get 1. So that means 1 is the limit. Very simple. Part B, when x is approaching 1, substitute 1 in place of x, right? So when you substitute 1, 2 into 1 is 2 plus 4 is 6. So answer is 6. That's it. It is so simple. Part C, when it is approaching 16, so 4 minus root of x upon x. So root of x, in place of x you put 16, so it will be 4 minus root of 16 upon 16. Now root of 16 is 4, so 4 minus 4 is 0. So 0 divided by 16 is 0. Okay, it's not undefined, it's 0. So answer is 0. Okay? Answer is 0. Next one, in place of x put -1. So 3 into -1 minus 3 upon -1 plus 1. 3 into -1 is -3 minus 3. -3 minus 3 is -6. In the denominator is -1 plus 1. -1 plus 1 is 0. So you can see in the denominator you're getting 0. So any number divided by 0, it's an error, it's error. If you press in the calculator, you'll see it's error. So if you're getting an error, or maybe a number upon 0, if you're getting it, that means limit does not exist, right? There can be another scenario where you'll get 0.0. So when you get 0.0, then you have to simplify, factorize, and then substitute the x value and solve, find the limit. Okay, so we'll now what we'll do, thank you very much to all the students who have submitted the activities. I have marked it and I've given the feedback. I don't think most of you got anyone got wrong, right? Any questions wrong, because it's so easy. All these questions that was given to you, it was so easy. So let's go and look at some more different types of limits, right, where we have to simplify. Right? Why we have to simplify? Because we'll get 0.0. So now the main objective of today's class is to calculate limits. To find limits of rational algebraic expressions, directly substitute in the expression. That's what you have to do every time. First you substitute. If upon substitution you get 0.0, then the limit may exist. Right? If you are getting 0.0, then only limit may exist. Therefore, you factorize, cancel, and substitute again. That's what you. I think this one, whatever I'm discussing here, a video on this I have showed it to you people in our last class. And then it says algebraic simplification such as factorization by common factors, factorized trinomials or difference of squares. So all these things, how to factorize, you have learned in year 9, year 10, year 11, year 12. Okay? So all these difference of squares and so on, you should know. You should know how to factorize. Okay? A useful technique of computing limits is using L'Hopital's rule, which involves the following steps. Now, L'Hopital's rule is a rule where you have to differentiate. Now, differentiate, I hope you are clear on that. Differentiate is something, it comes from calculus, differentiate. It comes from calculus. And you have already learned the basics of differentiation in year 12, last year. Okay? Now, how you differentiate is very simple. Okay? Suppose you have x squared. So if you want to differentiate y is equal to x squared, it will be dy upon dx is equal to, just bring that power which is 2 in front, it will be 2x, and minus from the power, answer will be 2x to the power 1. So answer will be 2x. So simple. Just take to differentiate the numerator, differentiate the denominator, and then substitute. So I will be showing you some examples on that. Don't worry. Now step 1, let's see. When you check the limit, when you substitute directly, you will get 0.0. So as soon as you get a 0.0, you differentiate the numerator and the denominator. That's step 2. And then once you have differentiated, now you put the x value. When you put the x value, then you will see you will be getting a answer. Right? There, if this limit is finite, that is positive infinite negativity, then it is equal to the limit of f of x upon g of x. So another situation can also be there. You can get infinity upon infinity, right? Positive infinity upon infinity, positive infinity, or negative infinity upon negative infinity. Then also you have to use this method, L'Hopital rule. So I will be not touching on that infinity part. I'll just show you when the scenario of 0.0. When you get 0.0, what you have to do.
Okay, so here's the basic polynomial equation.
Okay, sorry about that. This video is showing the how to factorize. Maybe some of you have forgotten. Right? So it will show you how to factorize. Sorry, not how to factorize. Sorry, it will show you how to differentiate. Maybe some of you have forgotten from last year, differentiation. So let's see the video.
Okay, so here's the basic polynomial equation. And to differentiate this, I want you to remember to always remember to times and take. It will help you when you do more complex differentiation, and especially when you do integration. Because start to integrate and get to things mixed up quite easily. So remember to take. Next, for 8x. Now here is how think about it in that and take. When you take 1 away from 0, and x to the power of 0 is 1. Anything to the power of 0 is 1. So that. So in general, if you've got a number times a letter and differentiating, use that letter and get the number left. If we differentiate 3, similarly, it doesn't even have an x, so that will completely vanish. And that's all we're left with. So every time you're kind of losing a power of x. So now we're differentiating to show that we differentiated the language y by dx. And that's just saying differentiate y with respect to x. So that x in the bottom is saying that's the variable. Okay, I'm going to give you 6 examples now. They are going to get more complicated quite quickly, actually. So have a get at the ones that you feel you can, and we'll go through. Okay, so do pause the video here if you go at some of these yourself. Otherwise, you can do them together. The first one we're going to times and take. The x will vanish, and so will 1. Now, on this one, I've actually used a different language. I've used f of x. Sometimes they use y, sometimes they use f of x. It's good to be exposed to both those languages. If you differentiated f of x, the way to show differentiated is to do it in a dash, f dash of x. And that's all that means. It's the same as dy by dx, it's just a different way of writing it. Now, all of these other ones are getting harder. You need to first before you can differentiate. What I mean by that is you need to write them in a way they've all got powers. So here, that 4 over x isn't very helpful at the moment. We need to write that as a power of x. So if you need to brush up on your indices work, do watch another video. Otherwise, you should know that's x to the power of -1. Now we can differentiate. Times -1 and 4 is -4. When you take one away from -1, you actually get -2. Watch out for that. Some people might be tempted to say it's 0. But it's not. Okay, let's carry on. This one needs to be written as powers as well. Got that one right. Just check you've got your powers okay and the fraction work is all right. Let's carry on. To prepare this one, we need to expand the bracket. Now we can differentiate. No problem. Okay, these last two, we've got fractions in. These are quite typical sorts of questions to get. You need to prepare them to differentiate, of course. There's a couple of ways of doing this, and my favourite way at the moment is probably to bring that up as a power of -1 and then expand the brackets out. Remember when you expand brackets that when you times the terms, you actually add the powers. So that first one will be 3 add -1, which is 4. Now we can differentiate. Okay, well done. If you got that on right so far, let's differentiate. Brilliant. Well done if you got that one right. There's a few mistakes you could make there potentially. These fractions aren't particularly easy, so make sure your fraction work is really secure. Well done. That's just a handful of questions, but I do recommend that you keep practicing those and do some from a textbook or from wherever you get your questions from. Differentiating needs to be right on your fingertips. You need to be able to do it really easily without even much thinking. So keep practicing until you get to that point.
Right, students, I hope you have understood whatever was discussed in this video. Okay, now we'll look at one example, finding the limit. This one, it says limit when x approaches 1 minus x squared upon 1 minus x. So when you directly substitute the x value of 1, you will get 0.0, and you know 0.0 is not allowed. That means limit may exist, but you have to simplify. So you factorize and then simplify. So when you factorize 1 minus x squared in the numerator, 1 minus x squared, when you factorize, you can use difference of squares. Remember, difference of squares is, I told you, I was telling people many times during the class, I squared minus b squared is equal to a plus b into I minus b. So similarly, for example, this is 1 squared minus x squared. So 1 squared minus x squared is 1 plus x and 1 minus x. Right? So let me repeat. I squared minus b squared is a plus b into I minus b. So 1 squared minus x squared is equal to 1 plus x and 1 minus x. So you can see in the numerator you have 1 minus x, in the denominator you have 1 minus x. Hence, you can just cancel. So you're left with 1 plus x. So in place of x, you put 1. Now you substitute. Yes, you have factorized first, you have simplified. Now substitute. When you substitute 1 in place of x, you will get 1 plus 1, which is 2. Okay. In the beginning, you were getting 0.0. After factorizing, simplifying, you are getting 2. Just one method. Okay. just algebraic manipulation. Now second method is using L'Hopital rule. You will still get the answer too. So let's see. L'Hopital rule means you differentiate the numerator, differentiate the denominator. Right? So when you substitute 0, you get 0. When you substitute 1, you're getting 0.0, right? That's okay. Now use L'Hopital rule. In place of, not in place of x, you differentiate 1. When you differentiate 1, you will get 0, nothing. Okay? But when you differentiate negative x square, you bring the power in front, so it will be negative 2x, see, and minus 1 from the power will be 1. 2 minus 1 is 1, so x power 1, so you don't have to write 1. So answer will be negative 2x. When you differentiate the numerator, when you differentiate 1, it will be 0, right? When you differentiate negative x, it will be negative 1. How? Because in power of x is 1, you bring that 1 in front, it will be negative 1x, and then 1 minus 1 from the power will be 0. So x to power 0 is 1, right? Any number to power 0 is 1. So x power 0 will be 1. So x will be eliminated. Only negative 1 will be left, right? So once you have done this, then you substitute 1. In place of x, put 1. Negative 2 times 1 will be negative 2. And then negative denominator. So when you do the calculations on this, you'll get positive 2. See? So using both ways, you are getting the answer. Then every time you'll not be able to use the algebraic multiplication because maybe the equation is very complicated. So you'll have to go back to L'Hopital rule, which you will find easy. Right? The only you'll only be able to use L'Hopital rule if you are smart in differentiating. So it's better if people learn how to differentiate. Those who still don't understand. Okay, so I think I will show you another video now on some of the questions on limit where L'Hopital rule was used. Oh, sorry, one example. Tell you people this example. I think this example was not in the notes, or was it there? Okay, let's see. Evaluate limit as x approaches 4, 2 minus root of x upon 4 minus x. I think this one is from a textbook. Eh? So in place of x, when you put 4, you get 0 upon 0, right? Okay. Now using L'Hopital rule, that means you differentiate the numerator and differentiate the denominator. So in this step, you can see you have differentiated the numerator. Numerator was 2 minus x power 2 minus root of x. Root of x is same as x power half. You have to always write in power form, then you will be able to differentiate. Now differentiating this, right? When you differentiate 2, you'll get 0, nothing. When you differentiate negative x power half, right? Negative x power half, you bring this half in front, it will be negative half x minus 1 from the power. So half minus 1 will be negative half. So negative half is in front, x power negative half, right? Bring the power in front and minus 1 from the power. You got this in the numerator. Now in the denominator, it is 4 minus x. So when you differentiate 4, you get 0. When you differentiate negative x, you get negative 1. Okay? How? Because the power of x is 1 here, then bring that 1 in front, it will be 1x, and then 1 minus 1 in the power, it will be 0. X power 0 is 1. As I said, any number power 0 is 1. So 1 times 1 will be negative, and the negative sign here, negative 1. Right? I hope I'm clear on this. So what you'll do, you'll be using these two, f dash of x and g dash of x. F dash of x will be in the numerator, g dash of x will be in the denominator. See, it is done here. See, now limit x approaches 4. The numerator has this part, f dash of x, denominator is negative 1, this one. Right? Now put 4 in place of x. When you put 4 in place of x, when you calculate, you will get 1 quarter. is the answer, or 0.25. See, before you were getting 0.0, now you're getting 1/4. So that's the way you can find the limit. I hope you understand, right? Okay, so now I will show you one video on another video on L'Hopital rule. Please look at this video carefully and don't try to disrupt as someone was doing in the last video.
Today, we're going to begin our studies of a very traditional topic in calculus, known as L'Hopital's rule, or for some of you, hospital's rule. Yes, I said the word hospital. Why? Because some of the questions may get very difficult, that by the end of it, you may need to make a visit to the ER room in the hospital. Well, what I'm going to do first over here is try to explain this by using some very simple examples, so we get the intuitive idea. Then in the next lesson, what we're going to do is justify it with a little bit of a theory. Then what really this topic is about is mastering the mechanics behind L'Hopital's rule and when to do what. So I'm going to bring back this very simple example that we've done before. And remember what I said about limit questions. The first thing is to evaluate it. Notice when you put in the limit, on top you'll get 4 minus 4. On the bottom you get 2 minus 2. So the answer is 0 divided by 0. When it was 0 over 0, we talked about the concept of this being an indeterminate form. Why is it indeterminate? Because when you look at it, you can't tell what the answer is. In this case over here, we looked at the question and we noticed that yes, we can factor this as a difference of squares. We can then cancel it with the bottom and we work out that algebra and eventually the answer will work and the answer will be equal to 4. Now, in this lesson over here, we're going to introduce a new way to deal with these indeterminate forms. In particular, the form of 0 divided by 0 and plus minus infinity divided by plus minus infinity. So why don't I introduce L'Hopital's rule using this example? So here's how L'Hopital's rule works. It only works on limit questions. And in this case over here, notice that first thing you need to verify is that you have an indeterminate form of the form 0 divided by 0. And once you verify that's the case, you can proceed ahead by using L'Hopital's rule. I'm going to indicate that using a small h. And what L'Hopital's rule is that if you leave the limit sign alone, and what it does is it tells you that you can differentiate the numerator and denominator independent of each other. So let me repeat that. You are not using the quotient rule. So you are not. What you're doing is the following. You first look at the numerator, you differentiate that, which will give you 2x. And the derivative of 4 is going to be 0. And then what you're going to do is you're going to independently differentiate the denominator. So here the derivative of x is 1, the derivative of 2 is going to be equal to 0. Notice what I end up with at the end of the day. This is the limit as x goes to 2. You have 2x divided by 1, which is just 2x. You stop and you evaluate the limit. When you put in the 2 over here, notice you're putting in 2 times by 2, so the answer is equal to 4. Yeah, so let me pull out the following example. Now, it is true that you can factor this. That is true. It's also true that you can use the definition of the derivative from first principle. But none of those methods will make your life any easier. They're all complicated. In this case over here, I want to demonstrate the power of L'Hopital's rule. Let me first evaluate here. If I put in the 1, on top you have 1 to the 1/5, which is just 1 minus 1. Divided with the bottom, you have 1 to the 1/7, which is 1 minus 1. So really, you got 1 minus 1 divided by 1 minus 1, which is 0 over 0. And this is the key right over here. It says if you have this indeterminate form, you are allowed to proceed ahead with this question using L'Hopital's rule. Now, the only reason why earlier on in the course we didn't invoke L'Hopital's rule is because at that time we were restricted from the rule and the question really wanted us to use the definition of the derivative from first principle to tackle the question. So mechanically carrying out L'Hopital's rule over here, notice that I'm going to say I will use L'Hopital's rule by this indication of this red H. And at the same time, I will leave the limit sign alone. So notice I'm not touching the limit sign. Here's what I'm going to do right now. What I would do over here is I'm going to differentiate the numerator and the denominator independent of each other. So let me start with the numerator. The derivative of x to the 1 over 5 will be the 1/5 will come down. You subtract 1 from the power, which will give you minus 4/5. The derivative of the 1 is just going to be 0, so I'm not going to write it here. So that's the derivative of the numerator. Then we're going to go ahead and differentiate the denominator. Notice when we differentiate that, the 1 over 7 will come down. We will subtract 1 from the power to give us minus 6 over 7, and the derivative of 1 will simply be 0. So let me emphasize again that we are using hospital's rule, for those of you who like the hospital, or L'Hopital's rule. But what we are not doing is we are not using the quotient rule. Now, before you jump in and do all your fancy mathematics, why don't you just try to evaluate this over here? So if I plug in 1 over here, notice what I get back. The top is just 1 over 5 times over 1 to the minus 4/5, so it's just 1. Divided by, well, the bottom is 1 over 7 times by, well, you plug 1 into here, it's 1 to the minus 6 over 7, 1 itself. So I'm not going to put that in. So at the end of the day, notice the 7 will flip to the top, and your final answer is 7 divided by 5. And this question really truly demonstrates the power of L'Hopital's rule and why it would be very beneficial for us to use this rule over here.
Okay, so I hope you have understood whatever was discussed in the video. Now I'll leave it to you people to answer these questions that is already in the worksheet given to you people. But now if you have any question, you can ask me now. We have time. I'll end the class here.